Hi, welcome back to Data Mining Video Lecture Series. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. In previous lecture, I explained briefly about what is frequent item set mining, the complex process that is generating the frequent item sets. So now I'm going to explain in detail, and we'll also quickly recall some basic concepts in this lecture. So here we are going to see what are the different frequent patterns, like frequent substructures, frequent sequences, etc. And we will quickly recap what are the basic concepts we discussed. I gave a detailed explanation in the previous lecture. And next, the association rule mining process. So what are the frequent patterns? Frequent, I gave, I think, enough explanation in the previous lecture. The frequent patterns are the item sets. It could be the item set or a subsequences or substructures. So that appear frequently in any database or data set. So for example, a set of items such as, these are all the examples which I obtained from the textbook of Hanan Camber. For example, milk and bread. So these two items appear frequently together in a transactional data set. Then that is a frequent item set. So what are the frequent subsequences and substructures, etc.? A subsequence such as buying first a PC and then a digital camera and then a memory card. If all this occurs frequently in a shopping history database, then that is frequent. So that is called as a sequential pattern. This pattern is repeated. So that is called as a sequential pattern. Similarly, a substructure. So substructure means it can be any structural form such as subgraphs, subtrees or sublattices, which may be combined with item sets or subsequences. So if any substructure occurs frequently, and then it is called as a frequent structural pattern. The structural pattern is repeated, frequently occurred, and subsequence is frequently occurred. So finding frequent patterns is an essential role in mining association, correlations, and many other interesting relationships among the data. So moreover, it helps in data classification, clustering, and other data mining tasks. So the finding frequent item set mining is an important data mining task. So let us quickly recall the basic concepts, though I explained all this in the previous lecture. So this is a transactional database. Here you can see there are two columns. One denotes the transaction ID. It could be any number. So that depends on the type of the database they are using, and the attribute, the set of values. And next, another column we have items bought. This is just only for understanding, and actually this information would be stored in a different format in our database. So here these are the items bought. So let us quickly understand what this transactional database represents, because that is very, very important to understand here. So the first number, transaction number, it could be anything. So let us say this is only for understanding. The simple values are used. So 10. So beer, nuts, and diaper. So that means this is a purchase done by a customer, and that if that is recorded in a transactional database. So, and that transaction has the items beer, nuts, and diaper. And similarly, the second transaction, you can see that the transaction ID is at 20. That is another transaction done by the same another customer, and he purchased the 3 items: beer, coffee, and diaper. Similarly, the rest of the transactions. So this is a transactional database. So the database could be any other also. So here this is a shopping like a market basket example, because it is one of the typical example of a frequent item set mining. So from this we are going to understand the basic concepts like what is item set, what is a k item set, what is a absolute or a support, the relative support, and what do you mean by a frequent. So first let us try to understand what do you mean by an item set. A set of one or more items is called as an item set. Set of one or more items. In this case, for example, this set like a beer and nuts would be considered as a one item set. Similarly, the k item set. K means the number of items in that. For example, x equal to x1, x2, and so on, xk. K items are there in this in any item set, and that is called as a k item set. For example, suppose this also like a 3 item set, because this has 3 items: beer, coffee, and diaper. And similarly, you can take this example, and this item set has 5. So this item, the length of this item set, this is called as a 5 item set, because there are 5 items in this set: nuts, coffee, diaper, eggs, and milk. So that is a k item set, that is based on the number of items in a set. And then absolute support. So previous lecture we discussed threshold or minimum support threshold. Here there are 2 types mainly, like absolute support or the support count of a item set X. So that is nothing but a frequency or occurrence of an item set X. So how many times that particular item set is appeared in a transactional database. So that is the absolute support or the support count. How many times? For example, if you take an item set, like let me take an item set that is having beer and diaper. So this item set, how many times in how many transactions this item set is appeared. So let us just quickly check this. So first transaction has the items beer and diaper, and second also has beer and diaper, third also has, but this transaction does not have the item set beer and diaper, and this also does not have the item set beer and diaper. So this item set beer and diaper, the support count is 3 out of 5 transactions in this transactional database. Next, what is a relative support? So relative support is the respective of the total number of transactions, like that is denoted with the small s. This is the fraction of transactions that contains x. So that is also called as a probability that a transaction contains x. Like suppose in this, like a beer and diaper, this item set appeared in 3 transactions out of 5, and this is a probability that a transaction contains item set beer and diaper. Next, a frequent item set. So what do you mean by a frequent item sets? So from the name itself, right, it tells that the frequent means it is appeared more number of times. It could be 2 or 3 or n number of times. So an item set X is a frequent if X's support is no less than a minimum specified threshold, or minimum support or a threshold. Okay, so this is like suppose like minimum specified threshold is, let us say, 3. So a frequent item set is X. If suppose if X is a frequent item set, and if X's support is not less than, that means an item set whose frequency or the count is 3 or more, not less than 3 or more, then that is called as a frequent item set. Okay, so that the support threshold would vary from one task to another, one database to another transactional database. So this will be set by the domain experts. So there is no like a direct rule or a formula to find out this minimum specified threshold or the support. So let us see few other basic concepts, like find all the rules. So a rule could be like if X then Y, okay, that is in the form of X and then Y. The minimum support and confidence. So that means how we have to check whether this rule is interesting or not based on the support and confidence. So what the support, how we can calculate the support and also the confidence, so that we can check whether a rule is interesting or not. For example, support yes, that is the probability that a transaction contains both the items X and Y. So that would be expressed as in terms of probability of A union or X union Y. Probability of X union Y. Then confidence, that is denoted with the letter C. So that is a conditional probability, because if a customer purchases an item, then what are the chances, okay, to purchase the item Y. So because the one event, right, purchasing a particular item depends on the another purchasing of another item also. So that is, there is a dependency among the items. So this is a conditional probability. That means the conditional probability that a transaction having X also contains Y. So here let us say the minimum support, that is 50%, and minimum confidence is 50%. So the frequent patterns from this transactional database are 3, that is beer frequency is 3, that's why it is a frequent pattern. Nuts also appeared. How many times it is appeared? 1, 2, 3. So it appeared in 3 transactions, so its frequency is 3. So it is appeared in more than or equal to 50% of transactions. So that's why nuts also a frequent item set. And diaper also, because its frequency, it appeared in 4 transactions. That means 4 customers have purchased the item, the product diaper. And also eggs is also another item set. Its frequency is 3, so that's why it is a frequent item set. Because so 3 by 5, that is more than 50%. So that is because the minimum support should be 50%. So these are all the items where their frequency, the frequencies, the support count is more than greater than or equal to 3. Next, another 2 item set like beer and diaper. These 2 items together appeared in 3 transactions, like a beer, diaper, as we already verified, right? So these 2 items together, beer and diaper items, these 2 items together appeared in 3 transactions. So that is more than 50% of transactions appeared. So this item set is also a frequent item set. So association rules could be expressed as like beer if beer then diaper, that is with the support 60% and confidence is 100%. We'll discuss in detail like all this. Now let us just understand a little bit in detail about this support and confidence, because these are very very important measures that is used to measure the rule interestingness, whether the rule is interesting or not. So that accordingly the business analyst, they will analyze and they'll go for the further decision making. So these support and confidence are the two measures of rule interestingness. For example, a support of 2% means that the 2% of all the transactions under analysis show that the computer and antivirus softwares are purchased together. So like if computer, or I would write a association rule like computer antivirus software. Okay, so that means if a customer purchases computer, then he tends to purchase antivirus software also at the same time. Okay, so and its rule confidence support is 2% and the confidence is 60%. So what does it mean? 2% of support means 2% of all the transactions under the analysis shown that the computer and antivirus softwares are purchased together. Okay, so among the 2% of transactions, 2% of transactions, computer and the antivirus softwares, these two items are appeared. And what does mean of the 60% of confidence? It means that the 60% of the customers, among this 2%, 60% of the customers who purchased a computer, they also purchased the software, antivirus software. So that is a confidence. So based on these two, so we'll measure whether the rule is interesting or not. So association rules are considered like the association among these two items. Okay, because these two items are first of all appeared together in a transactional database, and then we'll measure this interestingness of this rule, that is support, the how many transactions are having both computer and antivirus items together, and among this 2%, how many customers, right? How many customers they purchased antivirus also, right? The confidence of 60% means that so 60% of the customers who purchased computer also bought the software. So the association rules are considered interesting if they satisfy both the minimum support threshold and minimum confidence threshold. So as we discussed in the previous lecture, the association rule mining process comprises of two steps. The first one is of finding all frequent item sets. So in this, each items will occur at least of as frequent as predetermined minimum support count, that is a minimum support. So all the items or item sets, the support count should be greater than or equal to minimum specified support, this value. That is the first step. And next, second one, generating the strong association rules from the frequent item sets. So first step, we are going to generate the frequent item sets. Like suppose, let us say A is a one frequent item set, B is another frequent item set, C is another frequent item set. And also the two item sets like AB is another frequent item set, BC is also another frequent item set, AC is also another frequent item set. So these are all the frequent item sets. Like suppose there are n number of items in a transactional database. So from this, these are the frequent items. So frequent items means, let us say like a minimum specified threshold, minimum support. So let us say minimum support equal to, you could express in terms of a count or percentage also. Like suppose 30% we could express, or the support like some 10 you can. Okay, so 10 transactions or 30% of transactions in transactional database. If any item or item set appears more than or equal to 10 number of transactions, then that item set is called as a frequent item set. So we have to scan entire database and to find out the frequency of each item set. So, and these are the item sets. So that means the output of the first step. The first step, we are going to find out all such kind of a frequent item sets. The second step, so we have to, it is because as I said, it is a direct process. That means like if these are all identified as a frequent item sets, so that I could directly derive an association rules like A, B. Okay, so A is an item set, another is another frequent item set. Now I have to find out whether this rule, if A then B, is interesting or not. So to measure this rule is interesting or not, we use the support and confidence measures, so that then we will decide whether this rule is interesting or not. So I think, so the process of finding this item sets, frequent item sets, is the first step, is a costly process, whereas the second one is just directly we would derive, like suppose AB, and I could also write another rule like AC. Like we could derive the rules among these all frequent item sets, then find out the support and confidence for each rule, and based on that, then we will decide whether it is whether a particular rule is interesting or not. Next, as I said, the generating of frequent item sets is very complex process, because like suppose here only we have a 3 item sets like A, B, C. Suppose there are some 100 items. Suppose there are 10 or 100 items. So then the maximum number of item set would be possible, right? Possible item sets would be 2 to the power of 100 minus 1. So it is a big number. It is a big number. So to check, to find out all this, like 2 to the power of 100 minus 1 number of item sets, and scanning the database and finding the frequency and identifying the frequent patterns or item sets, is a very complex process. That means, because in the real world, if you go to any supermarket or a shopping mall, there will be a many number of items. So that is why it is very complex. So if even like suppose if you specified whatever the minimum support threshold, if you specify very small amount of threshold value, let us say, let us go back just quickly to the previous example here, this transactional database. Instead of the specified support threshold like 50%, that means half of the transactions. Like suppose I just want to mention the support count as 1. So that means the item should appear in at least one transaction. So then that means the beer, nuts, then all the items would be eligible, right? All the items would be eligible as a frequent item sets. If we increase this to 2, and if we increase this to 3, or like 4, 5, like this, so if the support value keep on increases, so then the number of item sets qualifying the condition would decreases. So for that purpose, to overcome the problem of this the overwhelming number of frequent item sets when we specify the minimum support threshold value is very low value. So the other alternative solutions were introduced. Those are closed and maximal frequent item sets. So let us try to understand what do you mean by a closed item set, or the closed frequent item set, and maximal frequent item set. So an item set is closed in the data set D if there exists no proper super item set. Super item set means, for example, if you take a B, C, and then AB, AC, BC, AC, like these are the super item sets we could generate from these sub item sets. So similarly, from these we could also generate like ABC, like ACB, ACB, like, so these are the super item sets. So for this, and this is the super item set, for this and this is the super item set. So if there exists no proper super item set, no proper means proper subset. What do you mean by the proper subset? Here X is a proper subset of Y. What does it mean? That means every item in X will also, so this every item in X will appear in the item set Y, but at least one item, so that is in Y, does not appear in item set X. So then this is called as a proper item set, super item set. So if there is no proper super item set, proper subset, this is, if there is no proper super item set Y such that Y has the same support count as, like suppose the support count is 6 and this support count is 6, right? So there exists no proper super item set Y such that Y has the same support count as X in the D, then an item set X is a closed frequent item set. There is no exist, right? Suppose here there exists a super item set with the same support count. So then it will not be considered as a closed item set, because it has a super item set with the same support count in the database. Next, if it is frequent, that means it's more than, it is appeared more than the specified number of or a specified threshold value, and that is called as a closed frequent item set. Next, maximal item set. So that means we are not going to, if any subset, if any subset have the same support count, then it will not be a super item set. So we'll consider only this one, so that we could reduce the number of frequent item sets. Next, another reduced form, that is a maximal frequent item set. So it is an item set X is a maximal frequent item set, or the max item set in a data set D if X is a frequent and there exists no super item set Y such that X is a proper subset of Y and Y is a frequent in D. Okay, so this is again, right? So in a database, if the X is a frequent and there exists no super item set, here the no proper super item set and there is no super item set. So that means there is a difference. It means the proper item set means the proper subset. Proper subsets means, for example, if X has items 1, 2 and Y has items 1, 2, 3, then X will become a proper subset of Y. Proper subset of Y, because Y has one item which is not there in the item set X. So these are the two reduced forms or minimal representation of the frequent item sets, so that instead of finding the frequent item sets, if you could find the closed and maximal frequent item sets, so the number, obviously when compared to the frequent item or frequent item sets, closed item set and maximal item sets, the number would be very small. So let us try to understand what is the computational complexity of this frequent item set mining. So let us just, though we discussed in detail, just let us summarize it. So how many item sets are potentially to be generated in the worst case? Like suppose if you have set a minimum support threshold at very low level, like suppose the 2, 1, 3, like very small percentage, then what will happen? So that leads to generation of many frequent item sets. So that is the one problem. Number of frequent item sets to be generated is sensitive to the minimum support threshold. If we increase, like suppose even like if you shift the minimum support threshold value from 3 to 4 also, there will be many number of item sets qualified as a frequent item sets. So when the minimum support is low, there exists a potentially exponential number of frequent item sets. Like if you set a minimum support threshold value, then many item sets will qualify as a frequent item sets. So another worst case time complexity, that is versus expected probability. That is, for example, if you take a Walmart, there are 10 to the power of 4 kinds of products. You just imagine. So then we have to scan for 2 to the power of 10 to the power of 4 number of item sets. So you can just imagine how complex, how big this number is. So the chance to pick up a particular set of 10 products is 10 to the power of 40. And what is the chance this particular set of 10 products to be frequent? That is 10 to the power of 3 times in 10 to the power of 9 transactions. This is the complexity. That means when we set a threshold, minimum support threshold value to very low. So now, before we discuss what are the algorithms to find out these frequent item sets, let us again quickly recall what do you mean by this downward closure property. Because as I said, when the number of items, unique items in a transactional database are more, then the item sets, the possible number of item sets will be very high. So but among those, like suppose let us say only 50% of item sets are the frequent. That means we would be wasting our time to process the remaining 50% of the item sets. So how to reduce this? How to reduce the search space? That means if a frequent item set is not if an item set is not a frequent item set, then we have to avoid scanning of that. So how we could avoid it? That is with the help of a downward closure property. This is also called as a priori downward closure property. What do you mean by this downward closure property? So that means when the item set length, for example A and B together, A, B, C items together. Suppose let us say, and this item A alone appeared in 6 transactions, and A and B items may be possible. They may both A and B items together may appear in at least 4 transactions, just understanding purpose. And ABC, okay, ABC items again, okay, in the worst case, it may also appear at least 4 number of transactions, not AB also, not more than 6 transactions. ABC also not more than 4 transactions, right? So that means when the item set length is increases, here this is a 1 item set, this is a 2 item set, and this is 3 item set. So when the item set length is increases, the support, that means the count, how many transactions have the item A, how many transactions have item A and B together, how many transactions items A, B, C together. This support count will remains same or it will be decreased. Okay, like let us say sometimes this ABC items may not be appeared in all 4 transactions. Like, so it may appear in 2 transactions or even 3 transactions and even 1 transaction, even 0 also. Okay, so there is such possibility. So that's why, so as per, and this property also, like from this is a increasing level. So the support value you can see here, D and its superset is 1 here. D's frequency is 2 and here CD's frequency is 1. So that means it is decreased. And now you can see here, and CD and its superset is 0 and again decreased. And similarly you can also go through this another example also. Here there are no much examples here. Like suppose here you can see the item set B frequency is 2 and its superset is AB and its frequency is 2, but it will not be more than 2. It will not increase. When the item set size is increases, the support will not increase. It will remain constant or it may decrease. So due to this property, they observed this property among the item sets, so that if any item set is not a frequent item set, then no need to check it's a super item sets. Like suppose if let us say the one is not a frequent BD is not a frequent item set, and there's no need to verify it's a super item set BCD. Similarly, if BC is not a frequent item set, and no need to verify its supersets ABC and BCD, because its supersets may the support count will be 1 or less than 1. So if BC itself is not a frequent, then its supersets will never become a frequent item sets. So this is a downward closure property. It's very, very important to understand. So this is just a brief about this, the downward closure property. So there are few approaches developed to find out these frequent item sets. Those are like the a priori is a 1. The first approach they have developed based on this downward closure property, and next one is a frequent pattern growth. Here the candidate generation process is eliminated from this, and another third one is a vertical data format approach. So thank you for watching this video.